Hi, everybody. Good afternoon. My name is John Hiddle, and I run sales, marketing, and customer success for Titan Cloud. And I'd like to welcome everybody to the second part of our fuel optimization webinar series. Today, we're going to be talking about the complex subject matter around inventory variance and why speed and precision really matter and can deliver great results to your bottom line. I want to remind everybody a couple things. I'm going to do a quick intro on Titan, very brief, and then introduce our speakers. But also, this is part of a three-part series around frictionless fueling, making it easier, making a seamless interaction with the consumer. That was session one. We talked about flow rate identification, nozzle down, tank shutdowns, anything that'll get in the way of customer having a great experience at the pump. Today, we're going to talk about fuel inventory variance control. How do you get tighter into your inventory variance? How do you understand what's, how the fuel is flowing through the supply chain and where some of the shrink happens? What are some of the anomalies that happen, and how can we really get a lot more precise in that measurement? And then in a couple weeks, we're going to go through and talk about our last part in the series around fuel logistics. If everybody saw our announcement yesterday, we acquired a company called TrueFill that does supply optimization and supply chain optimization and logistics, load planning, carrier management. So now we're offering a full terminal to consumer, end-to-end supply chain visibility, supply chain optimization offering. So we're really looking forward and excited about that as well. Okay. All right, and we have coined the term fuel asset optimization, right? So many of you are familiar with Titan Cloud and what we've been doing in the market. We pioneered the whole idea of grabbing information directly from your IoT devices, your gauges, your pumps, and bringing that into a comprehensive platform. And we've grown over the years to encompass not just compliance. Many of you might know us as just compliance tool, but now we offer benefits in many different areas, right? Obviously, we still help customers reduce risk of compliance. We also help them reduce maintenance costs and maintenance spend, make sure when we send a service request out there, it's for the right reasons and for the right, we have the right information. We also are attacking the fuel problem over the last couple of years. We have done a lot of work in this area as the reason for this webinar. And then also in the supply and logistics area as well. So we feel like we're now end-to-end supply chain optimization across all ecosystems, across multiple departments in the retail and fleet companies, but also multi-company collaboration, right? The carriers and some of the service providers, as well as the store and the fueling location. Okay. We've done this a lot, 85,000 and growing sites that have access to across multiple verticals. C-store is obviously our big one. We go all the way from the top, I think 4 out of the top 5 C-stores use Titan in some form or fashion. We go all the way down to the 5-store chains, 2-store chains. We're fully international now with our acquisition of Leighton O'Brien last year. Many of you saw that. And we're also doing a lot of work with fleets and other carriers, XPO Logistics, Avis, Hertz, Ryder, those kind of companies. All right, it's my pleasure to introduce the 2 speakers today, and we'll get right into the heart of this. I'll do a quick intro, and then you guys can introduce yourself. But Brent Cusack and I have been working together for the last year and a half. So, he's was the undisputed king of compliance with Circle K, and had, I don't know, thousands of stores under his belt. But grew up in the industry and has done very small gains as well as the big. So Brent, glad to have you here. And then Michael Lewis comes to us from Leighton O'Brien, all the way from Australia. So, Michael, what time is it where you are?
It's 4 a.m. at the moment.
4 a.m. So really appreciate you getting on the phone. And my fun fact for Michael, he has a degree in forensics, which is going to come in very handy as we get into why tank charts aren't very good today. How can we make them better? And we spent a lot of time yesterday trying to help me understand it, and I don't know if I do. So I'm going to let Michael explain it. Also has a degree in enzyme kinetics. So I don't know really what that
Yeah,
is. It sounds really, really good.
that's from a different life ago.
All right.
But,
That's great. Well, guys, take it away. I really appreciate it.
Thanks, John, and good afternoon, good morning, everyone. Like John had mentioned, today we're going to be talking about fuel inventory variance, fuel inventory reconciliation. Really why the speed and precision of determining and matching up variance is actually beneficial, and how it impacts organizations. So we're going to kind of give you a base overview of the current state of the industry. Kind of talk about challenges with tank charts. Manufacturer charts, programming of ATGs, talk about the exceptions and anomalies that are actually items that software can actually pull out and identify for the end user, right? That root cause analysis that really helps people drive additional value out with through their variance analysis. And then the overall benefit of reducing environmental write-offs and reducing loss or write-offs associated with fuel loss across an organization. And wanted to just kind of highlight with the graphic here, when you think about fuel inventory reconciliation or inventory variance, right? It's really a fairly complex problem that kind of expands the full fuel supply chain, right? So organizations deal with miscalibrated terminal meters that are introducing the wrong amount of fuel to the haulers, that in turn could result in theft events or expansion and contraction of fuel that's actually dropped into the tanks, right? So it impacts just about every functional group within an organization. And there's so many variables, and a lot of those are what we're going to be talking about today, that impact and add to variances within an organization. So I want to just really highlight initially the complexities of what we're going to be talking about today and the breadth of what we're going to be talking. So we're not going to be able to talk about everything. We're going to talk high level. But certainly, as an organization, we'd love to talk to companies about how our products can benefit them in the long run. But just wanted to plant the seeds about what's on the agenda for today. So overall, when you think about the state of the industry, right, organizations are using their ERP systems, the PDIs out there, the different ERP systems that are that have really limited functionality on managing variance concerns, right? They're generating variance reports, they're providing visibility to where there's loss, but they're not actually able to generate maybe the root cause of loss, or trigger in ways to actually help you to kind of reduce the overall loss, right? So the data that's actually fed into these ERP systems are coming from tank charts, which we're going to show you through this presentation, or have a lot of inaccuracies in them. And then they're coming from gauges, which are fed off of the tank charts, which in turn have errors that are baked in, right? That drive additional variances across your location. So, these items show up in a number of different formats, as well as the delivery. When you're trying to reconcile deliveries at a location, those are attributing to as well, right? So they're driving issues such as loss, fuel loss across sites, delays in payments, because your teams are spending so much time reconciling the deliveries that it takes time to get those payments out to the haulers. Increased write-offs, like we were talking about earlier, because you can't validate where that loss is coming from or put steps in place to actually mitigate that loss. It's decreasing the productivity of your teams. It's they're spending time investigating things that are false alarms, that are losses that aren't necessarily true. They could be related to temperature, and all of these are things that we're going to be talking about in a little bit more detail as we go through. So there's a huge amount of human error that comes into these items, of people collecting information, the timing of when they collect it, the frequency of how they're collecting it. All of those invoke issues that drive loss and challenges on managing variances across organizations. So just to try to set the stage, and Michael, I know you do this from an international standpoint, but are there anything different that you see kind of on a global scale that show up as issues, or kind of from the current state?
Typically, what we can see is that a lot of companies, no matter where they are based around the world, they're trying to investigate fuel losses with one arm tied behind their back. There's a lot of variances that can be controlled. whether that be calibration or temperature that we are going to get into. But we want to sort of encompass that the goal of inventory variance is get a handle of what you can control, and then direct your operational teams to be able to investigate those actual issues, whether it's a tank leak or a meter calibration or a stuck probe. If we can really tidy out the noise that's within that variance that's been reported on a day-by-day basis, you'll find that you'll be able to have a lot more efficient workflows into fixing ongoing problems.
Yeah, great input, Michael. While people are answering that question, right? I mean, I've been in the industry and been doing the wet stock side for quite a number of years, and one of the things that was really impactful for me when I first started was that leveraging this new technology kind of outside of what the ERP systems offer, it's kind of like pulling your blinders off. It gives you visibility and a much more granular view of what's actually happening within your tanks, your tank systems, and within Variance, right? So you're able to really get to that root cause, and all of those are things that we're going to be answering and showing some of those benefits in here today.
And I guess just adding to that, just having the equipment at site, just having the fancy equipment, having your TLS 450s installed in site isn't going to immediately have an impact in your fuel reduction. I've just come from a client that was regressing because they were so frustrated in trying to determine where their fuel losses were coming from the end of day variances. They went back to manual dipping. So it's really important to continue to peel back the layers into where your fuel losses are coming from.
Absolutely, drives a huge amount of operational costs for those systems.
What are the biggest challenges that your team are facing in minimizing inventory variance and fuel losses? Is it leaks and spills that is your major issue? A lot of people, is it calibration issues? Is it issues with your equipment when we're talking about issues with your gauges or potential issues with your meters? Is theft a big problem in your area of the world? And also, is it, when we're talking about equipment issues such as calibrations, is it your tank charts? Are you just not too sure that when you're reconciling your fuel on an end of day basis or a monthly basis, that the losses or potential gains that you're observing within your network, is it associated with purely just an ATG calibration error?
Absolutely. And the things we're going to be talking about here, right, is that, the kind of the foundation of the data that's feeding your variance is the tank chart that you're using, right? So if people are familiar with the tank charts or not familiar with tank charts, right, what these are is when a tank is manufactured, right, the manufacturer will develop a chart that's based on inch readings that are converting into gallons. And that's based on a precise reading for a tank, right? There's no deviations for that or no anomalies within that calculation. But the biggest challenge is when that tank is actually installed in the ground, there's compaction issues, there's environmental issues that change the dimensions of that tank. So it doesn't necessarily match the manufacturer's charts. So when you think about, the company, like in the example we have over here, right, is that they're assuming that they have a specific 10,000 gallon tank. But in actuality, they've got a different type of tank, right? So it's invoking variance because they're gaining the wrong readings from the systems. And I think in my experience, one of the things I see is like, especially with acquisition companies, right? When they purchase a location, they really have no visibility to what's actually installed in the ground, right? There's no crystal ball to say this is exactly the size, the dimensions, all of the environmental factors that are associated with that. So it's really a guessing game as to what's actually in the ground, and companies do the best they can. But there's what we're going to be talking about is the technology that helps you kind of get a lot more visibility into what's actually happening. And this is this really kind of is highlighting the fact where you have one that's really close. I mean, there's a lot of situations where technicians pull a tank, they may assume it's a 10,000 gallon tank, but in actuality it's a 12,000 gallon tank, right? So those little changes that are happening with charts, with companies that are using manufactured charts, they invoke variance every time readings are taken, deliveries are made. So there's a lot of challenges in those. And I know, Michael, you were talking about yesterday some of the examples that you've seen over the years with this.
Oh yeah, look, we've seen clients that have bought sites from small dealers, and they've got the volume correct, but the orientation of the tank was vertical, but it was programmed for a horizontal build. And we see, talking about environmental factors, we have customers in regions of the world where there's extremely heavy rain seasons, and that will disturb the ground. It'll shift the movement of the tank. It'll put the tank chart out, or even just daily operational tasks like cleaning probes and somebody not putting the probe back in the right spot. There's a whole bunch of environmental reasons and a whole bunch of non-static reasons as well as to why tank charts will become inaccurate over time. And it's a very difficult thing to maintain a master data set of a very large network of what are all my tank capacities, what are all my tank diameters, am I confident with that data set, as you have as you mentioned, Brett?
Yeah, and some ERP systems, what I've seen historically is they don't give you the ability to track every single individual tank configuration, right? They'll bucket a 10,000 gallon tank into one tank chart. So every reading that's coming in, if it's not the right tank chart, again, it's adding variance to the overall system and driving additional costs that really don't need to be there. So great example in the survey, Michael. It looks like the majority of the people indicate that equipment issues are some of the biggest challenges associated with this, and tank charts is the second largest issue there. But I think what we see in a lot of this, right, is that certainly equipment issues are a big segment, but the foundation of this is getting the right chart, making sure you're maintaining that right chart, and we'll show you kind of what that looks like as we kind of move forward.
Yeah.
So let's put this in context of what's happening in the field when an ATG, right? A lot of clients, a lot of companies have automatic tank gauges that are set up to match the tank chart from the manufacturer, right? And those tank charts, right? They leave a lot to the imagination, right? You're assuming that exactly what's down there, but those systems are set up really on what we call a 4-point or a 20-point setup, meaning that what they're doing is they're taking 4 entry points, which is typically the full volume, 75% of capacity, 50% capacity, and 25% capacity, and they're making those entries into the chart, and then the chart is interpolating those values to come up with the readings in between, right? So there's challenges with that interpolation. We're going to be talking about how some of those relate, but just like we were showing on the other ones, those oblong shapes or the over compaction, the interpolations aren't going to give you the right volume readings when it's reading out the inch readings on the tank system because of those challenges. And then Michael, you kind of mentioned yesterday that the routine maintenance and testing events where they're pulling those probes out. That changes the location of that probe and the readings that probe is going to be providing out. So I don't know if you want to provide additional detail on that side.
Yeah, basically just any time, even if you had a perfect install, your tank's sitting perfectly flat on the ground, and you've got a perfect calibration on your tank to begin with. Any sort of environmental factor, where it be anything that's going to disturb the relationship between the height and volume of your probe, any sort of shift in the tank, wear and tear over time. Fiberglass tanks, quite often they'll bulge or they'll compact, in order to, deal with the weight of the ground around them. In some areas where we have a lot of earthquake patterns as well, anything that will disturb that relationship of the ATG probe height and volume is going to eventually put your probes out.
Absolutely. And you could go to a 20-point setup, right, which is going to give you more monitoring points and a shorter interpolation here. But at the end of the day, the challenge still kind of comes in that you could have deviations between that are throwing off your overall readings.
Yeah.
So as we shift over, let's give you an example of what we're talking about, with the challenges with interpolation, right? So if you take those 4-point settings that we were talking about within the ATG, if you have a deformation like we're showing here on the bottom right of this tank between the 10 and 20 inch mark, what's happening is that deformation is going to change the volume of fuel that's stored in that segment of the tank. So when that probe is at that height, the tank chart in the ATG is assuming that it's a uniform volume, and it's providing the level that's specific to that chart. When in actuality, in this case, what we're showing is that indentation is actually reducing the volume of fuel by 149 gallons. So it's impacting the volume when that probe is at that height. So again, it's invoking variance as you're getting deliveries, as you're getting sales, and you're beginning and ending readings through that level of visibility. And that at the end of the day, the challenge is that that level of deformation is not necessarily it's not exact, right? At the end of the day, you're seeing something that's a lot more uniform, right? You've got an oblong tank with a number of additional imperfections in the system, right? The tank that we're kind of showing here shows like a lining that's peeling off that tank, and it's changing the internal diameter of those systems. So a normal tank chart and a normal ATG programming is never going to catch that level of deformation. So these are the challenges that organizations face on a day in and day out, trying to reconcile a variance where you have these imperfections, these deformities of the tank systems that are actually invoking additional variance points into the variance readings that you're capturing, either from the ATG manual stick readings, how that probe's actually moving up and down the tank system. So, Michael, before we kind of jump into how Titan Cloud solves this challenge for organizations, anything else you want to add on the deformations at all?
Yeah, just as your deformation can change over time, or even if a gauge can be installed incorrectly or just be not correct in the initial install, it can be quite a challenge for a lot of operational teams. Let's say you've got a gauge where you're seeing positive variances when the tank's selling because the gauge is not dropping down as quickly as what's expected through when you're measuring it against the POS sales. Once you get a delivery, you're going to get a loss, and some clients might see that as potential delivery theft. So they might target an investigation if the gauge is out so far. And we've seen scenarios where clients have thought that they were having something like a leak occurring or delivery theft occurring at a site, and it was purely just because the gauges were so out of calibration that they couldn't see past that visibility, and their operational teams were, with a fair bit of evidence for what they had with the technology that they had, we're targeting their loss investigations through that type of process.
Absolutely. And so, how do we solve this at Titan Cloud? How does our technology help kind of generate a foundational chart, right? What we term a fine-grained tank chart that takes into account all of these abnormalities of the tanks, all these deformations, right? And so, if you think about what we're doing is really, we're leveraging the data kind of on a continual basis, right? So high frequency data that we're capturing from inventory transactions. We're accounting for temperature. We're accounting for the deliveries, like the inputs and the outputs that are coming from the systems. We're doing this on a high frequency basis in a much more granular view than what you're getting with a typical tank chart. And we're doing that over and over and over again. So we're viewing it, we're validating it until we take into account all of those different changes in inch and volume readings across that tank. And then once we've validated that, once it's gone through our algorithms, we're generating a precise chart that's accounting for all those deformations, all the changes in the inch to volume calculations that you would see in the typical chart. And we would generate a chart that can be used to kind of program your ATG, that can be provided out to your haulers so that they have the most accurate information as they stick before and after a delivery. So that allows you to account for all of those changes within the tanks. And I think the biggest thing is that this process is not necessarily a one-time process, right? Is that we're actually doing this using the usable volume of your tank. We're not requiring you like in historical strapping, right, where you're filling the tank all the way to the top, you're selling it all the way down, and you're doing that multiple times to to build a tank chart. That doesn't necessarily account for issues with the tank that results after that strapping's done, right? Because that tank does change over time, right? That delamination that we saw in that photograph earlier didn't happen all at once, right? It was a gradual process. So we're constantly restrapping, we're constantly readjusting the tank chart to make sure that it's the most precise for those systems. Michael, anything else you want to add on this one before we jump forward?
Yeah, no, just to also just summarize that, you could think of it like a personalized tank chart for each individual tank that you're constantly monitoring with, and we're using historical observable data from that particular fuel system in order to regenerate, in order to constantly keep your tank charts as accurate as possible.
Absolutely, great point.
And moving through, I'll give you guys just a little bit of context. One major question that I get from a lot of clients is, how do I know that the tank charts that you are providing me are more accurate than the tank charts that I'm currently using in my field system? And quite simply, we can provide them imagery, we can provide them outputs with using our software to tell you exactly where the improvements are being utilized, where they're being seen within your fuel system. So this graph here just represents a month's worth of data, and it's just reconciled inventory, sales, and delivery data that's been reconciled over an hourly basis. And we're just plotting the variance that we're determining on an hour by hour basis over this monthly period. And if I can just get you to focus on the gray line, that variance is jumping all over the place. I'm getting positive variances when the tank's selling. And then when there's 3 delivery events that occur during this month, and I've got losses whenever the delivery event has occurred. And the variance is highly erratic. That means on every day when you're closing out your readings, when you don't have a delivery, you're getting gains in your fuel system, in your end of day variance recordings. And then when you get deliveries, you're getting massive losses. And the way that, as we historically profile these fuel systems and as we update the tank charts, we can show you on the exact same plot and the exact same figures, using the exact same sales and bill of lading data, but using our interpreted ATG and our fine-grained tank charts, we can plot the same variances, but show you our improvements. And in this factor here, the red and yellow lines are the improvements that are the inventory variances based on our fine-grained tank charts. And as you can see, there's a lot less positive negative variation when we're using that data compared to the raw ATG observations that we're observing from site. So how does that look at the end of the month? Well, at the end of the month, there was only a 2 litre loss in this fuel system using our fine-grained tank charts compared to the ATG that was observed at site, which was over 500 litres. And we measure our improvement factor by how much variance we're reducing in your overall variance on a month-by-month basis. Is there anything you want to add there, Brent?
No, I think you covered it really well, Michael. I know for the timing standpoint, we'll probably just kind of touch through, keep on the high points, but I think you're kind of leading into the temperature side here.
Yeah, that's right. So we could. So after you get control of your ATG charts, there's also another very influencing factor in your variances, which is the fuel temperature. And quite simply, fuel will expand or contract. It's a hydrocarbon. A lot of clients will see in colder conditions, they'll see quite a lot of differences in their fuel variances during winter compared to summer. And what's important to realize is that fuel temperatures can have a significant impact in the day-to-day variance or the month-by-month variances that you observe at site. So the imagery that we're showing you here is the top image is just, again, plotting the variance over time, and this is over 18 months worth of data. So I wanted to grab some seasonality into this trend, and this is actually taken from a site up in Scandinavia. And the graph below hand is just that same 18 months worth of data, but I'll just get you to focus on that orange line, which is temperature inside the tank as it's moving through the season. And essentially what we're trying to determine is that when you're delivering hot deliveries into fuel tanks, the delivery volume, that hot delivery will encompass a smaller volume once it's in the tank. So once that delivery has adjusted to the fuel temperature inside the fuel system, that fuel delivery is eventually going to occupy a smaller volume. So you may see losses in your fuel system because the fuel is reducing within the tank. But you're not actually losing any fuel. It's just a pure thermodynamic reaction of the temperature decreasing. So what we do is we will measure the tank temperature, and in some scenarios, in really cold conditions, we can also measure pumps that have automatic temperature compensation installed in them as well. And we can accommodate and we can adjust for those variances based in the changes in temperature that's occurring within the fuel system. And just to show you, Brent, if you have any additional examples. Daddy?
No, just looking at time, I just want to make sure we're keeping in time for it. But I think we covered the core things on the temperature side, right? Is that technology can help kind of spot the fact that what's a true temperature anomaly, and then what variance is outside of the temperature realm.
Yeah. And once you have control of your temperature and your ATG calibrations, you should start to see better reconciliation and better and more tight variances within your fuel systems. And one important factor that you may be able to you'll start to see an improvement in is your ability to reconcile deliveries. So, for example, in Australia, we ran a test with a client on just under 1,200 fuel systems. And before we updated their tank charts with our fine grain tank charts, they were having a 94.5% delivery matching rate. So they were measuring what the ATG was saying was delivered to the gauge versus what the BOL was. And they were accepting anything that was within 20%. So if you had a 10,000 litre delivery and the delivery was 9,500 litres, we would accept that delivery. And they were investigating 449 unmatched deliveries on a monthly basis. And then over a 6-month period, we updated these 1,900, just under 1,200 fuel systems with our updated fine grain charts. And we were able to not only improve their delivery matching percentage, so the amount of deliveries where we get a tick on the box in what's being delivered into the tank via the BOL and what the ATG is reading, but we were also able to reduce that delivery matching tolerance to 5%. So the difference between those deliveries that were being measured from the ATG and the BOL was reduced to anything that was less than 5%. So the amount of investigations that they were investigating for February was only 25. So a massive reduction in operational management and operational costs in their ability to, and it also allows them to target their investigations, which may be associated with fuel theft or short deliveries, a lot more efficiently.
Absolutely, a lot more visibility into what's happening on the delivery side of things, right?
Mm-hmm.
Yeah. And so what that, when we talk about, inventory variance as a whole, right, and the ability to be able to refine the tank chart to address temperature related issues, BOL related issues. Now with that fine grained view, we're able to isolate the anomalies that are happening within your supply chain, right? So, the temperature, the evaporation, the expansion, contraction that's occurring across the supply chain, spillage that might be happening from the terminal to the hauler, to the delivery. Meter drift that's occurring at the terminal, right? Those meters that are dispensing thousands of gallons into the hauler's truck can have the same calibration challenges that the meters dispense into your customers' cars have. So having that visibility, at the terminal and at the site is absolutely critical to kind of understand where that loss is coming from. And then theft events that might be happening, right? So it's a broader level of visibility into the root cause of what the remaining variances that you're seeing are actually attributed to. And this is a small segment of that. But as we kind of drill into the next segment of that, Michael, you want to talk about the dashboard visibility we provide?
Yeah. So as you mentioned, as we've got the remaining variance and we can associate that to different types of trends that we observe, we can basically isolate different patterns that we observe in the data and associate them to different types of alerts. So as you can see on the alarm exception dashboard, there's a series of alerts. Some of these are associated with fuel variances, some are associated with administrative issues. But what we can do is we can build workflows based around each different type of alert. So think of these like ATG alarms, but they are IP derived alarms that are using reconciled data. And we can isolate different types of alerts to different fuel systems that will allow clients or allow operations teams to customize their workflows based on the type of alert that's being visualized, which is being classified by the different type of variance that we're observing at site.
Yeah, great point, right? Everybody works in the same platform. You're breaking down silos that might be happening across teams to be able to give that visibility. And Michael, kind of maybe you can share some information on some of the types of anomalies, some examples.
Yeah. I'll keep this high level, and of course we can go into any detail about it offline with anybody who wants to really get into the nooks and crannies of these alerts. But I'm just focusing on, say, on three alarms that we have here that are associated with inventory variance, and particularly fuel loss to ground scenarios or theft scenarios. We can isolate something like a sudden loss alarm, which just targets a single one-off loss event over an hourly period, which we customize these types of losses to be associated with something like fuel theft being taken directly from the tank because that fuel is not being reconciled through the pumps, or potentially a worst case scenario, which would be a catastrophic tank breach. And the advantages of these alerts is they're very fast acting. They usually find issues a lot faster than traditional inventory reconciliation methods, and they can isolate the individual loss, which can be difficult to monitor over either an entire day or an entire monthly reconciliation. And then other alerts like the quiet time assessment alert, which basically just looks for losses when the fuel system's not in use, and which can be associated with tank leaks, and something more complicated like the short-term analysis alert, which will try to profile the fuel system to know exactly how much variance we're expected to see as fuel moves through certain periods of the tank. And we can then isolate if those losses increase, we can isolate that to either a tank leak, a line leak, or a catastrophic meter failure. And probably one thing that's important with these types of alerts is they kind of work off each other. So if we have a short-term analysis alarm going off because we have seen an increase in losses, but we don't have a quiet time assessment alarm going off, so we can identify where we can help target where operations teams should be investigating. Because if we can be sure that there's no fuel leaving the tank when the pumps aren't being used, but we're seeing losses when the pumps are used, it's most likely that we're seeing an issue with either a line leak or a meter. So you can play the alarms off each other to build and customize your workflows to give you the most targeted investigation profile.
Absolutely. So get very granular on the visibility of what's actually causing the variance, right?
Yeah, exactly. And a benefit to the system as well is we can help identify other types of administration issues that does have a large impact in your variances. And one of them is blend ratio exception reporting, and this is quite a big issue in North America. So we can, down to the pump, once we're monitoring, as we're monitoring the reconciliation through your fine-grained data, is we can isolate which pumps that you have for blend setups are not in the correct ratio compared to what you would expect them to be. So using this example here, we have a 12 hose system where the client believes that they have a 70-30 split on unleaded versus premium for their blended grade. But we can isolate into two scenarios. One where in pump 11, you had 80% of fuel was being drained from the unleaded tank and only 20% was being taken from the premium scenario, which can push you off spec to regulators. And then in another scenario, like in pump 12, we have too much fuel being taken from the premium tank and not enough fuel being taken from the unleaded tank. So you're actually, unknowingly cheating yourself in the quantity of fuel that's being taken from the premium fuel system.
Absolutely. I mean, just guaranteeing that you're selling at the right octane, right? You're none of the programming on a mechanical or the setup on a electric meter is incorrect, right? It gives you that additional level of visibility there. So, just to close things out on our side, when you look at this, and this is a real life example we had for one of our clients where they were experiencing a write-off of about $3.5 million a year, and their teams were spending over 1,500 hours in investigation efforts, time that was spent not necessarily running, in value-added services, but once we refined their tank charts, once we were able to identify the BOL, the temperature issues at their locations, and provided that anomaly detection to give them additional benefits, we were able to reduce that overall write-off across the organization to $560,000 in the next year. So tremendous amount of decrease, improvement in overall operating expenses and the overall write-off. Then the efficiency for their team was significantly increased, where now they could spend more time on value-added efforts to really drive additional benefits overall. But as a tank chart benefit, it was an 84% improvement over what they were historically seeing just within their normal ERP process and their historical process there. So significantly improve their overall workflows or overall processes just by leveraging technology to drive additional benefits across the organization. And I know we moved through some of this stuff really quick, but again, we want to make sure we have enough time. So John, I'm going to turn it over to you, and then we can let you kind of finish things up, and we go to questions then.
That's great. Really appreciate it, guys. Brett and Michael, thanks so much. It's a complicated but very important issue that we're helping companies work through, and so hopefully that was helpful for the audience as well. Okay, first question: does this chart process take into account variance due to how full or empty the tank is?
It absolutely does, right? We're, like we mentioned in the tank chart process early on our strapping process with a fine grain, right? We're using the usable capacity of the tank, so you're not necessarily having to fill it all the way up. So we're managing that at the level that you're normally operating that tank system, and we're building the chart based on that information. When that tank volume changes above the level that we've analyzed, we're constantly adjusting that and rebuilding for that additional level. So we're always looking at the full volume, the empty volume capacity, and we're making sure that the tank chart that's developed is exact based on that current useful volume.
Yeah, that's absolutely correct.
Great. Next question. Tank probes have thermistors. I think I'm saying that right. Are you suggesting the use of the different temperature monitor?
No, so we're taking the temperature from the gauges when we're doing our temperature compensation in the tanks. But there's also, well, I'm not too sure, maybe in the US, but in Canada and in a lot of Scandinavian countries, they will install automatic temperature compensations on the pumps, so they can also measure the difference in the thermal temperature of the fuel as it moves from the tank through to the pump. And we can also take that type of temperature compensation into account. So any type of expansion or contraction that's occurring within your fuel system is being handled by the system.
Great question.
All right, next question. Is any hardware needed on the ATG console for Titan to see the data?
Yeah, so we capture data in a number of different ways. Standard inventory data we'll capture just from the communication of the ATG. We would increase the polling frequency in some cases to have more frequent data sets. But the next data set we need is actually transaction level data. And we could get that from the gauge if that gauge had that technology. So, a connected EDIM device, electronic dispenser interface module, that generates that's connected to your forecourt controller that provides transaction visibility is one option. It's not necessary. A lot of organizations and tanks don't have that. So in the cases where they don't have it, we would use an import in from your back office system that would be transaction level data that provides the start and end time of the transaction, the volume of the transaction, all the critical data points. So those are two of the main options for it. Worst case scenario. In some certain occasions, we might have to look at a hardware device to give transaction data, but most all scenarios, we're able to at least get a back office feed that provides that data without the
we've actually got we've actually been developing and now have it ready, a API for PDI, right? So the PDI enterprise system, it's a Titan app that can go in and then pull transaction market basket data right away. So even early on in the formation and the founding of Titan, our mission was to be a pure software company, and so no hardware is needed. You could use some if you wanted, but no hardware is needed to deliver the results we're talking about.
Yeah, and the final piece of information for the ATG recalibration would be the BOL deliveries. So ensuring that we're receiving at least 2 out of the 3 essential criteria, which would be either the ambient delivery volume, the temperature adjusted delivery volume, or the gantry temperature. If we just need 2 out of those 3, and we can calculate the other one.
Yeah, great catch there, Michael. Thanks.
All right, next question. How does the system handle situations where there may be data gaps or inconsistencies in fuel inventory records?
Great question. Great question. We can. It depends on the level of the outage. If it's a small outage, if you're within an hour, if you've missed 20 minutes of ATG polls, our system can reconcile that into in pretty easily. If you have a large outage of, let's say, a week where an ATG has gone down at a site, we would just adjust that data period, so we're not taking into account any variance once the ATG comes back. We would just cancel out that period where that gap goes. If we can't apply a sale to a reconciled ATG period, then we're not going to make that assumption. We just cancel out that period. But yeah, we can handle large outages. And again, that question comes with a piece of string. How large is the outage for? Small gaps, not a problem. Large ones, we can basically block out that period.
No, that's great. Yeah, we'll go back a slide here and remind everybody that next up, our next webinar is May 22nd at 2 p.m. So it's the last third part of our 3-part series here. From chaos to clarity, demystifying fuel logistics. So getting back into the supply chain a little bit more. How do we minimize fuel costs, minimize transportation costs, maximize your revenue through the chain, and minimize all these anomalies we're talking about. So that's next up, May 22nd. Register now if you want. And I really appreciate everybody's attendance. Thank you so much for coming. Thank you, Brett and Michael, for a great presentation. And we look forward to seeing you at Sigma. If people are going to be at Sigma, I'll be there in Austin, and we'll be we're posting a lot on LinkedIn, and hopefully everybody got the handouts. So I'll point to those again. If you want to download the handouts, we'll do that. And then we'll make this available for people that could not make it on our website as well. All right.
Absolutely. Thanks, everyone.
Thanks,
Appreciate
guys.
everyone. Have a great day.
Thank you.